Welcome to section 2.3. In this section, we're going to take everything that we've done basically in section 1 and 2, and we're going to kind of combine it together, and we're going to make some graphs. So for this section, you will need graph paper as you're working on things, but we're going to kind of show you the basics. Okay, as we go through, let's start with the first definition we have. The parent function. Okay, the parent function is the most basic function of any family. And each function that we talk about, like parabolas or logs or quadratics, all have what we call a parent function. Now, we're going to be dealing with lines, linear functions. And the linear function parent is the y equals x line. And you'll notice there's no plus or minus, there's no number in front of x, it's a single x. Now, the reason this is the parent function, this parent function, if you look at the graph over here, the parent function has a slope of 1. It goes up 1 over 1. And it also goes through the origin. Okay, so as we look at this, the x-intercept, we want to look at two things when we talk about lines. One is slope. And as you look at this, we know that the slope is 1. The second thing is called a y-intercept, and our question is, where does it cross the y-axis? Well, if you look, it crosses the y-axis right here at the origin, but normally we don't say a point. What we say is just the y number that it crosses at, okay? And so in this case, it's 0. And so what we're going to be doing is using slope and y-intercept to help us write functions, and then on top of that be able to graph them. So let me move up. Let's talk about slope-intercept form. Now this should be familiar. Slope-intercept form is the equation y equals mx plus b. M we talked about yesterday was the slope. B is the new letter we're going to introduce, and that's the y-intercept. Okay, and that's basically where does it cross the y-axis. In order to graph these equations, because we're going to give you a bunch of different equations, we want to graph it in what we call slope-intercept form, which is this equation here. In order to do that, we first have to get the equation to look like y equals mx plus b. And some of you might be saying to me, but Ms. Shapanik, aren't you going to give it to us that way? And the answer is sometimes. You will also see things in standard form, which we're going to talk about a little later. Okay? Now, we want to identify, first and foremost, the y-intercept. Okay, we want to know where does it cross the y-axis. And so what we're going to do is plot the point 0, and I'm going to use the letter B here because I don't know exactly what the number is, but I'm going to plot that on the y-axis. Because if it's a y-intercept, it better happen on the y-axis. Then we're going to identify our slope, and here's the big thing. We want it as a fraction because we need to know how many up and how many down we have to move, okay? The numerator we said was the vertical movement, rise over run. Think about it this way, rise over run, which means positives move up, negatives move down. And you'll notice I'm using arrows because I think that's easier. Denominator, I'm going to shorthand this because I don't have a bunch of space, is the horizontal movement. Guess I don't need to. Positive moves to the right, negative moves to the left. Now, I'm going to change color here a minute because I want to make this very clear. I don't ever want to move to the left. My goal is to always put my negatives on top. And if I put my negatives in the numerator, then I never have to worry about going left. I'll always move right. And I'm going to hint to you, and I'm going to keep getting you into that because I think it's the easiest way. Now, as we move up, let's actually graph. You'll notice here I put a note without a graphing calculator. I want you to understand the ins and the outs of how this works. Okay? What I'm going to look for is my value of b, which in this case is 1. What this says is on the y-axis, I go up to positive 1, and I make a dot. That is my y-intercept. Now, my slope is negative 3 halves. Now I'm going to write it as negative 3 over 2 because from that point, from that y-intercept, I want to move down 3 and right 2. Okay? And you know what? Actually, I'm going to make this a little bit bigger. Sorry, that got pretty big pretty quick because I want you to be able to see this. As I take it, I start from my y-intercept and I go down 1, 2, 3, over to the right 2, and I plot a new point. And then I go down 1, 2, 3, over to the right, plot a point. Now, what happens if I can't plot all of those points? Then what I'm going to do to go in the other direction is I'm going to go up 3 and I'm going to go left 2. And if I do that, it'll help me get the other way. So if I go up 1, 2, 3 and left 2, you'll notice as I make this line that I end up getting the same pattern as I'm going through. And we have graphed our first line. Now let me slide it over. Let's try another one. If I give you y equals 3x minus 2, negative 2 is my y-intercept. So on the y-axis, I go down to negative 2 and I plot my point. The 3 then is my slope. The problem is we said we want slope as a fraction, so I'm going to write 3 over 1. Because it's a positive 3, I go up, and a positive 1, I go to the right. So from the point I just made, I go up 3 and over 1 to the right, and up 3 and over 1 to the right. If you can, I'd go back. So go down 3 and left 1, and again, you can kind of complete this. You want to get as accurate of a graph as possible, which means you plot as many points as possible. Okay, so this is the idea so far, and I just wanted to make that a little bit bigger so that you could actually see it. Let's try and get this back to where it should be. But we are going to be graphing lines today. Now, flip the page. All right, now, I told you there are going to be some times that we don't have things in slope-intercept form. And the reason is we're giving them to you in, in standard form. Standard form looks like this. AX plus BY equals C. And that says X and Y are on the same side. What we are going to do, and you have two possibilities for this, and I'm going to show you both ways. Normally what we did in section, and I'm going to just side note this because it's not here, but in section 1.4, we would solve an equation for y. Now let me show you how that looks when we look at part A. Okay, so I'm going to go to part A and I'm going to solve the equation. So if I have 2x plus 3y equals 12, I keep the y, I want y, so I move the x by subtracting. So 3y equals. Now, I'm going to make you write the x first this time because we know that slope is in front of the x and we tend to look for slope first. So then I divide it by each of them by 3. And I get an equation that says negative 2/3 x plus 4. If I do that, I now can graph. Now the problem with this method is sometimes both of these numbers, the y-intercept and the slope, end in fractions. And we don't know how to plot fractions very well on our y-axis. So this doesn't work all the time, but here's how it works. I go up to a positive 4, 1, 2, 3, 4, and I go down 2 and over to the right 3. So down 2 over 1, 2, 3. Oh, 1, 2, 3. I'm going to erase that. Okay, down 2 over 1, 2, and 3 is kind of out here. And I end up getting this line. Okay, so this one ended up working out. Now, there are many a times it won't. And so what we suggest is when you have standard form, you skip solving the equation. Instead, you find two things, the x-intercept and the y-intercept. The x-intercept you get by plugging in a 0 for the y. So you're trying to eliminate the variable you don't want. I can find the y-intercept, and if I want the y, I don't want the x, so I put in a 0 for x. So let me show you that method in part B. If I want the x-intercept first, I'm going to make y 0. So I take 4 times x minus 2 times 0 and equal it to negative 6. Now these go away. So I have 4x equals negative 6, and if I divide by 4, x equals negative, and I'm going to put it in a decimal because it's a nice one, 1.5. What that means is if I go on my graph, this is on the x-axis, I can go to negative 1.5. Ooh, I'm in a big, and I can plot a point there. Okay? I'm going to put my y-intercept above, but if I'm going to find my y-intercept, I make x 0. So I take 4 times 0 minus 2y equals negative 6. This goes away. If I divide by negative 2, then y equals a positive 3. So I go on my y-axis up to 3, and I plot a point, and all I have to do now is connect those 2 points. Most of the time in standard form, using the x and the y-intercept is the better method. Sometimes, though, you can get away by solving like you did in part A. Okay, so just kind of be aware of that as you're going through. Okay, now I'm going to keep moving on because there are a couple of special equations that I want to talk about. And these are kind of some of the harder ones, I think, because you expect maybe a different result than you get. I want to read this equation to you in part A. This says every y is 2. Okay, and if I were you, I'd write that out. Every y is 2. What that means is if I make a table of values, x can be anything I want as long as the y is 2. So I'm going to pick the easy ones, 0, 1, and 2. These are now points on my graph. So 0, 2 is here, 1, 2 is here, 2, 2 is here. And what I end up finding now is that I have a horizontal line. Okay, oh, hello, I can write it right below. We'll get rid of that. Okay, so if I look at that in the same way, for part B, this says every x is negative 3. So I can make a table, and I can pick every x to be negative 3, and y can be anything. So I have this point negative 3, 0, negative 3, 1, negative 3, 2, and you'll notice it's a vertical line. Now, some people memorize, okay? You have that right. You could say a y equation is a vertical, an x equation is a, a y equation is a horizontal, and an x equation is a vertical. I never memorized. If I can find a way around memorizing, I will do that. And the easiest way around memorizing is figuring out what does it mean and how can I use a table to make that work. Okay. Last one is a story problem. A value of a copier decreases $600 per year. If you purchase the copier for $4,000, write an equation to represent the situation. Now, I just want to get the equation, and then I'm going to stop and we'll do the rest in class. We know a per year is where our variable is going to be. Decreasing means subtract. So if I look at this, why is the cost currently? I spent $4,000 on it originally, and it decreases $600 per year. Now, I'm going to have you do C to get your notes points. When will it be worth $500? Set up your equation and get me an answer. We will work on what does a graph look like and things like that when we get to class. That's it for section 2-3. It gives you kind of the idea. We will be doing a lot of graphing. Don't forget you'll want graph paper.